Hello. Hello. Good afternoon. There's more people coming. Good afternoon. Good afternoon, Melanie. Thank you. Melanie wins and now it's happening. All right. Here we go. Good afternoon, Melanie. Thank you for saying so. Good afternoon, Vicky. And also welcome back and thank you for saying so. And good afternoon, Victoria. Thank you for saying so. Good afternoon, Caitlin. Thank you for saying so. Good afternoon, iPad. Let's talk about that. Or I would love to get some, wait, oh, sorry. Crises of biblical proportions. Hold on. So maybe if the iPad could privately identify itself, that'd be awesome. Wait, more people coming. Where are we? Good afternoon, Abid. Thank you for saying so. Good afternoon, Gabriel. Thank you for saying so, and welcome back. Good afternoon, Joel. This is a big class, right? Good afternoon, Roger, and welcome back, and thank you for saying so. Good afternoon, Zoe. I love it. All right, I love the typographic enthusiasm. Let me change my. Oh, thank you, iPad. I appreciate. Oh, okay, great. Thank you. Oh, and David with the video. Hello, that's awesome. That's points. That's exciting. And Abid with the video. And then Raina. Now we're talking. Hello, Abid. Hello, Raina. Hello, David. Don't worry, I'll not keep singling you out, even though I totally will. No, I won't. Oh, and Bridget. Hello, awesome. Oh, great. Oh, and thank you, Lear, for saying so. And yes, remember, especially for those of you who didn't have me last semester or don't know, please do remember, no, all of this stuff, and hopefully it'll get more and more clear. All these things like showing video, you it's encouraged. You can get points for it, but it's not required. Here comes soon. Oh, hold on a second. But every time you do it, you can get points for it. And please understand that you don't have to do it for the whole period or something to get points for it. As long as you do it at all in a period, you can then submit for the points. I hope that's clear. So don't worry. Don't not turn it on because you're afraid that later you're going to turn it off. By the time I'm like doing physics and stuff, I'm going to be so in my own head, I won't notice anyway. Really, really. So thank you for showing video. Those of you who, yes, thank you, David. Thank you, Abid. Thank you, Raina. Thank you, Bridget. Thank you, Gabriel. Also, and hello, and yes, and thank you, Lear, for saying good morning, Kai Ann. Good to see you or hear you. Good afternoon, Sonam. Welcome back. Here goes more people. Okay, well obviously we're gonna get started in a second. But also, again, for those of you who are just still we've only had one class, so those of you who are getting used to some of my slightly more unusual grading systems or whatever, please know that. Oh, hello. Okay. Then even if you're not showing video, those of you like Victoria, Vicky, Kyan, and Sonam who are showing anything other than a black square, like they can submit into the portal that says avatar, even though I can never pronounce it right and I'm probably not even using the word correctly. But like as long as you show anything that's not a black square on a given day, you can submit to that portal. All those extra portals can be used anytime and multiple times until the last day of classes, May 14th. And again, some of my grading, these things are unusual. You're welcome to ask me at any time for further clarification on this business. Oh, and good afternoon, Andre. Oh, welcome back. And good afternoon, Sanam. Welcome back. Awesome. Wait, was Andre here last? Okay, awesome. Good to see you guys again. Um, Oh, and Vicky, right. Oh, and so for example, what Vicky is doing right now, right? It's not video, it's not an avatar, it's an animated avatar. That's a portal. Like basic, right? I mean, she can submit for points in the portal that says animated avatar, and she can do it every time she does that. And it's not just her, anybody can. So again, hopefully you'll just get used to how this all works. But if you don't, you can ask me at any time, email or text. I won't be insulted to have to explain it more than once. Good afternoon, my fiend. Good to see you. Okay, so again,
Good, good
oh,
morning, Professor.
oh, good morning. Oh, and was that Muhammad who just said that, or was that Mafi? Was
That's me, Mohammed.
okay? So thank you, and to remind everybody. So what Muhammad just did. For example, he just used his voice, right? Like, how exciting is that to me? The answer is very, very exciting. So there's a portal for that. So exciting, it's making me cough. So there's a portal called like Speak Softly or Forever Hold Your Chat. I mean, some of the portals have ludicrous names. I apologize. Some of them you have to like actually open and read the instructions to see what they mean. But like Mohammed today could go to that portal. I mean, and where it says speak softly or forever hold your chat, and he opens it up and he sees the instructions say for one time that you used your voice, you could submit. So he doesn't have to like submit an FBI dossier with tape recordings. He doesn't have to prove that he used his voice. He just has to remind me. Like I'll remember. I've now been talking about it for 3 minutes already. I'm going to remember. He just has to open that portal and write like today, Monday, February 3rd. Like I use my voice to say hello. That's it. And he gets the points for that. Could he do that again on Wednesday in the exact same portal? Like could he submit another document on Wednesday? Yes, he could. He could do it every time he uses his voice. Another question, can he double dip? I'm just using Muhammad as an example. Like obviously anybody, or I'll go back to a different example. Like Mafine is showing an avatar, right? She can double dip. Like anything that she's doing, any portal that applies to anything she's doing applies to anything she's doing. So Mafine, like at the end of tonight, before midnight tonight, when she opens up game turn two, because today is the second class, so it's like turn two. You'll like every class is a turn that's due before midnight, and all you have to do is open up that. And I know this is repetitive for many of you. I'm just trying to make sure we're all on the same page. Every single class that we do, the ratio of physics to this kind of discussion will be higher and higher. Like it'll be more and more physics and less of this discussion every day. I just want to make sure it's all clear. So, like by midnight tonight, anybody and everybody takes that portal that says game turn two, and you just add a document. And most of you did this last time. I think it was clear. Most of you did it for turn one for class one, but you just type out like any way that you participated today. You could, I typed hello in the chat. Good, fine. Or what I'm trying to make clear with this example now is you can double dip. Like Mafine could write, today I showed an avatar, which is not really an avatar, like a picture of myself. Instead of doing a black box with my name, I put a picture of myself. That counts as a form of participation. So she can write that in game turn two tonight, but she can also like literally open up the portal that says avatar and submit it there. If there's any other portals that apply to, she could do, you could double dip, you could triple dip. I hope you get the point. Hopefully you do get the point. Okay. And again, if I'm using your name at all, it's because you're doing something good, not something bad. So I'm just like using you as an example. Okay, hopefully that's clear. Like Joel, same thing. He can submit for an avatar. Aminata, oh, to hello, good to see you. She could submit for video. That's awesome. I'm just saying, it's great that you're showing video. Thank you. That's awesome. Hopefully, oh, and there's Lear showing the video like you promised. Okay, so hopefully you get to put all of this stuff. Believe me, I'm going to shift my gears and start talking about physics in a minute, unless there's questions. But I just want to make it clear again, because even if you took Physics 203 at John Jay, even if you had one of my esteemed colleagues whom I loved, like if you had Mercedes Talley or Hema Walters or whatever for Physics 203, then yes, like a lot of things are similar and all of that. But this whole like system of participation points, I don't think they do in the other classes. So I just want to make it clear to all of you. And make it clear that all of this stuff, all of these points for various forms of participation, plus all of the points from regular physics homework that we're about to start going over right now, all of those points, yeah, they add to your average at the end of the semester. Yes, they can make a huge difference in your grade. They literally could make the difference between a B minus and an A, or a C minus and a B, or like failing and passing, right? They can make a huge difference. But at the same time, they're all optional. Just to be clear about that again, you don't have to. So they're all in effect extra credit. All the physics homework, the participation points. If you don't do something like game turn one or game turn two, or when you don't get, or even a physics homework, I wouldn't recommend that. But if you don't do a physics homework, you don't get a zero, you don't get a punishment. You just don't get the points and the points for it. And the points can make a really huge positive difference, especially if you're not totally confident exam taker. Okay, so hopefully that's clear. So, okay, stop me if it's not. But now we're going to start. I'm just looking. Is there any Victoria? Hello. Thank you for showing video. That's awesome. Thank you. All right. So in a second, I'm going to shift gears and start talking about the homework that was due, 10 minutes ago, the homework that was due today's class. I'm going to start going over it. I'm going to start dealing with it, um, and trying to give you a sense of what I'm looking for when you do these homeworks, et cetera, et cetera. Couple of things. We're not going to finish going over it today. I may have already warned you of that last time. We're not going to get to the end of it today. That is always true. It's a very big homework. It starts sort of straightforward, but it gets very hard by the end. It spans a lot of topics that we need for the rest of the course. So it's going to take us a little while to unpack all of homework one. Again, we will not finish it today. I may give a bunch of answers today so you can see if you're on the right track or not, but we're not, but just understand that we won't finish going over it today. Understand also that when I start going over it in a minute, first I'm going to be very painstaking about the step method. Like I'm partly going over the first question of homework one to show all of you exactly what I want out of the 5-step method. Again, you might not have done that in like physics one, wherever you took it. But this 5-step method that I'm going to like walk you through today is what I want on all homeworks and on exams, for good or for bad. It's how I grade. It's like, what if you ever don't get all the points on something? It's because I couldn't find all the steps. The steps is what you get the points for. So much so that as long as you always have all of the steps on all the problems and you're like clear about them and they're the correct steps, then even if you have incorrect answers at the end, it's still totally conceivable to get an A on homeworks and homeworks and homeworks and exams. Like you could get A and in the course. You could get an A in the course even with a lot of wrong final answers, as long as you're showing all the steps. Conversely, you could have a lot of right answers, but if you're not showing the steps, then you don't get all the points. I mean, then you don't get all the points, just to be clear. So I'm going to do question one of the homework now in a second, walking through the steps as I like as I'm looking for them. Um, yeah, okay, so that's okay. So you can see the board, right? Okay. Um, And one last, so, it may bore some of you. I mean, because I know, I'll even cut to the chase. Look, the answer to the very first question on the homework that was due today, the answer to the very first question on the homework that was due today is F equals negative 30 newtons, I believe, if I'm looking at the right homework. Okay, it's negative, I think. Wait, I better actually look at I think it is. Yeah. The answer to the very first question is F force equals negative 30 newtons. Now I'm getting that. So first of all, if you got that or you understand that, then good. Then you already know some physics. But I'm also saying it right away now to get it out of the way because I want to make it clear to you that that's not all that I'm looking for by any means. I'm aware that many of you could do that in your head, and I'm proud of you that you could do that in your head, but that's not what I'm looking for on the sheet. I'm looking for a lot more than that. So if you got the right answer, that's cool. I'm not being sarcastic. You should like be happy. That means we're like, we're all on the same page together. But now you should like be able to relax and pay attention to how I'm looking for you to break that down in the homework. Even if you right now don't think it's necessary to break that down, you think it speaks for yourself. I don't. Okay, so I'm going to show you what I'm looking for, and I'm looking for these steps on questions that are comparatively straightforward, like maybe that one. But I'm particularly looking for these steps in questions. By the time we get to questions that are hard, that we don't right away see how to do them in our head, that's when the steps are like really important. That's when they'll get you out of a, sorry, that's when the steps will get you out of a jam when you don't know what to do. They are there to give you something to do when you don't know what to do, like honestly, but they don't work. They won't help you unless you've actually practiced them in situations where you do know what to do. Okay, so this is all my big sort of defense of why even those of you who already know that the answer to question one is negative 30 newtons, I still want to show you how to get all the points on a homework or an exam question like that. So that's what I'm about to do. But last thing, sorry, I think there's things in the chat or there's someone in the reading room. Yeah, and there are things in the chat. Um, okay, so hold on a second. Oh yeah, yeah, yeah. Okay, wait. Yes, it is. I forget why Yediah said yes, it is, but okay. Oh, yes, it is. Oh, got it. Thank you, Yediah. Got it.
The professor that was replying to your one. Okay.
Wait, that was no, and thank you. By the way, that was voice. You just got points for that. I didn't mean to cut you off. No, and I appreciate that was from when I was asking, like, is this the correct first homework question? Is that what that was? Is that what you're saying?
Yes, professor.
All right, awesome, awesome. That's great. That's great. Look, again, I'd rather this be about you than me. Like honestly, like I'm bored of myself. It's much better. So yes, good. Thank you. So, but now to the others of you in the chat, is it all right if I outline this question? Wait, there's two. Okay, let me answer so I'm obviously going to go over this and some of the questions will sort of be clear but first of all, about my leniency, like it says, like great question about Beats question. Am I going to be lenient for the first homework for the 5 steps? Well, yes and no. No, that's a very fair question. I mean, yes, ultimately, yes. But here's the deal that I want to make clear to everybody. I'm going to start going over it now. Here, if you turned in the homework on time, this is always true. It's true certainly for what I'm about to say is certainly true for the first homework, but it's actually true for all the homeworks. As long as you turn in a responsible first draft before it's due, like by the time it's due, and by a responsible first draft, particularly from here on in, I mean like where you attempt most of the questions and you basically follow my procedures. Like you give me a fresh document, you show that you know what's expected in the class. Like you give me a fresh document, you and you attempt most of the steps on most of the questions from here on in, or including now. If you made a responsible first draft for a homework by the time it was due, then no matter how many points you did or did not get on that draft, I'm telling you right now, you absolutely can revise and re-upload until you get all the points. That's very important to understand. Like really important to understand. So in terms of my leniency or whatever, like so especially like right now, I'm gonna go start going over this first homework. Okay. Now, some of you just turned it in like right on time, like right before class, which is fine. That's fine, but I didn't see it yet because I was like teaching the other class. But many of you, but it's fine. Like as long as it's not late, whatever you did, even if you got it all wrong, or even if you didn't follow any of my procedures, as long as you turned in your draft and it was respectable before it was due, then the leniency is that you may have to fix it. You may have to redo the whole thing. But when you do, you'll get all the points. You will not be penalized for the fact that it took you like more than one draft to do it. In fact, I like love the idea of doing revisions and more than one drafts on things if we're trying to be research scientists in the long run, right? Right. So, but especially those of you, I got to say this before, those of you who turned in this homework like like yesterday or last night or in enough time that I saw it a couple of hours ago, you may already have a score on your homework, and that I'm assuming, in fact, like perhaps one of the people in the chat. If you already have a score on your homework, let me be very clear. If you already have a score on your homework, what that means is that that means I'm acknowledging you turned this sucker in on time. I'm giving you feedback as fast as I can right now. It won't always be that way. I'm giving you that score is feedback. That score means you absolutely can get all the rest of the points. I'm telling you how to get them. So the leniency, and this is not just true for the first homework, the leniency is as long as you try respectably a first draft. I'm going to say this again. I know I just said it, but as long as you turn in a respectable first draft by the time the homework is due, that's what you're turning in is a first draft. And whatever score you get is just kind of telling you how much more work you have to do to get the rest of all the points. which is what I'm now going to explain in class with this one. So I'm going to now show you how to do the steps that I'm looking for. You may find them really annoying. You probably will. Or you may go, oh, well, I mean, if I had known that yesterday, I certainly would have done that. Like I did, but I'm telling you, so fine. So do it tonight. Like, okay, you totally, as long as you got any score on your homework, it means you can get the full score. And even if you didn't, if you turned it in on time, you get what I'm saying. So the leniency is that you just keep revising and uploading until you get all the points. And that's always going to be true in the class. Eventually, we're all going to fall behind and not like the stack is going to be high enough that it won't be worth like going back to homework one and like redoing it for one extra point. Like that won't be worth. But as long as the portal is up, you can do that. Okay, okay, I hope that's clear. If that's clear, like maybe put in the chat, like, yes, that's clear. I mean, if you ask the question, maybe say, yes, I understand the answer. Last thing about it though, too, when I say revise and upload, it is very important that you keep the other drafts there. Don't take down, don't like destroy your old work. It's like just a really bad personal habit to do that. You put effort into your old work, even if you think it's like not perfect. So what? So, so if you're looking to get all the rest of the points on this homework, and there definitely is time to do that, next time you'll submit a new document to the same portal, but don't take down the old document. So there's a button. There used to be a whole complicated way of doing this now, but the other class told me I think now Google Classroom has a button that's and you could confirm it's something like add document or resubmit or something. Do that. Like don't take down your old document, resubmit the homework with a new document. And that way, also, any points that you've already gotten, you'll still have those points. You're just going to get more points now. If you hit the resubmit button or the add file button, maybe you can, it's one of those, you can confirm if someone wants to check. Then Google will notify me. It'll literally, and it actually works really well on my end. I'll literally get a notification that says, like, that'll show me you already have a score, you already have a document, like you're totally on time in the class, but you're giving me more now to give you more points. Like I love that. And it works. So okay. So
Professor, can I ask a question, please?
yes, please. Yes, sorry. Yes, please.
So
Yes.
you're going to upload our grades in Brightspace or
Oh, okay. So that's a very good question. It's a very fair question. But no, I think we made this clear last time. So for good or for bad, I don't even know how to use Brightspace. Everything is through the Google Classroom. Hopefully your name
okay.
is, yeah. So everything is in the Google Classroom. And there's a good news and bad news of that too. And I apologize. Like all your grade. So this is what all your work and the grades on your work will come back through Google Classroom, like including even this homework one. A lot of people already got it back with numbers, and the numbers will improve. But the one thing I that I can't do yet in Google Classroom or Brightspace, because my grading system is this a little bit complicated like this, there's no button that you can press yet where you could literally see in Google Classroom what your total grade is like right now at any moment because it doesn't understand my system of adding up all the points. So, and I apologize for that. I know that. So you can always see all your scores. And if you understand my system, or if I remind you of it, you can add up your scores and get your grade at any moment, but it won't add up for you. So if you're ever, this is you, Lear, or anybody, if you're ever panicking about your grade, and yeah, if you're panicking about your grade in the class at any moment, if you're like, I see all my work, but I have no idea, it looks like I'm getting a D in this class or something, like just send me an email or text and we'll set up like a phone call or Zoom or office hours where I'll walk through with you and say, no, 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 this is how it's working. And really right now you have a B or something like that. And I'll remind you how you can add up. Okay. But that's a very fair question. So wait, does that answer your question, Lear? Or yeah, okay.
Yeah, thank you very much.
Okay, thank you, thank you. But yeah, that's to everybody. That's the one thing I'm working. I wish you could just press a button and see, but I have not figured out how to incorporate yet to do that. So just ask me at any time. But okay. Okay, so we're gonna go. Did I? Oh, and then there was this other question in the chat. Is it all right if I outlined it as question one? Oh yeah, I think David's question in the chat. I think I understand it, and I think it's a good question. Yeah, like, well, and you'll see in a minute when I start doing it, but yes, as long as for each question, it is totally explicit to me. Here's the person's step one. Here's the person's step two. Here's a step three. That's, yeah. I mean, so if you're at one, two, three, four, yeah. I mean, just be clear. Like you don't have to write GDP if that's what you're asking, but you do want to distinguish the steps. Okay, so I think it's time for me to do this. Yeah. And also with this business of resubmitting or adding a document, like I was saying a minute ago, that's very important for all these physics homeworks, but also it applies. Like if you show video every day, then every day just resubmit or add a new video screenshot to what's already there in the portal. It's like it applies to both. But okay, so let's start doing this homework. So what we're going over, first of all, I'm going to switch screens for a second just to make so we're all on the same page. And also in case you're watching this later on a video or whatever. Sorry. So what we're about to go over, right? This is what we're about to go over. Excuse me. Um, this is a situation. We're going to start and we're going to do question one. And after we do question one, I may just sort of give you answers for the rest for a while, just so you could see, but we're going to right now do question one. So this is the situation. This is what was due today. Yeah. So you can screenshot this now also if that helps. I don't know. But so let's go. Oh my God. Sorry. Hold on. I'm having coordination problems. Bear with me for 1 second. Okay. Okay. Not to drag this up, but one thing, notice, like I switched screens, right? Like I switched screens from the question that I was showing on the screen to a fresh document where I'm doing out the answers. That's symbolic. That's what you need to do too. Like just to be super clear, we don't want our homeworks or our exams or anything written on the original sheets. There's a million reasons for that, but you want to pretend everything is like a blue book, like from exams, and you're doing it out fresh on a fresh, clean document that can either be like a tablet, like I'm doing, or it could be typed if you're good at typing out math and typing out diagrams and all that kind of stuff, yeah, or you drawing it out on paper and then scanning it in. But it's like a fresh document, and the goal of the document always, especially now that we're in Physics 204, the goal is what I call self-sufficient document, meaning once I get rolling with this, even though I'm answering all these questions that somebody assigned me, I'm doing it in a way that no one ever has to actually know the original questions for this to make sense in physics. Like the goal is to produce a document that you could hand to anybody who knows physics, any other professor, or anybody in a journal, like a published journal who knows physics, and you could just hand them your document and he walks them through from beginning to end. Here's a situation. Here's the physics principles. Here's the physics work I did. Here's the physics answer. Like it would stand on its own as correct physics or incorrect physics that somebody could look at and they don't have to be in our class to know. That's the goal is we're trying to change, we're trying to turn arbitrary homework assignments into like things that could actually be physics arguments or derivations or proofs like in a physics journal. That's okay. So I started a fresh new document. I mean, I wrote homework one on it, but okay, thing on a spring, I put my name. All right. So now I'm going to first and foremost, I'm going to do step one, the diagram and the fact pattern. I'm going to draw a diagram before I do anything else. I know that the homework sheet already provided me with a diagram. Sometimes the homework sheets will, sometimes they won't. My diagram will be very similar to this diagram, of course. It better contain all the information for sure that this diagram did, but it's going to be similar, but it's going to be by my hand, my way. It's not going to be an electronic copy paste. It may look, it's okay. And yeah, so it's my version of this diagram is what I start with. So something like this. Okay. Oh, someone's here. Sorry. Okay. So notice I'm doing diagram. There's my diagram and fact pattern. So here's the fact pattern. Okay. So this is all my step one. Now, notice a couple of things. Yeah. And again, like I said before, I know this first question is, well, I hope is not the hardest question in the world. I understand that. I understand again, you might think you don't need to do all this to do the question, but you do. For me, you do. Um, but so notice a couple of things, and again, we're doing this now to develop the habit for when things are harder. I mean, I just can't emphasize that enough. But notice what I'm looking for in the diagram. Like, yes, I have all the same information that came from the original sheet, but what's really the purpose of this diagram? It's not just a picture. The first thing you'll notice is that the diagram is fully labeled and it's labeled with letters, like not numbers. That's generally what we do. It's labeled with K, M, X, and X naught. So part of you'll know that you've done a proper diagram, a diagram that serves its purpose. If every single letter, every single constant or variable that's ever going to be used in the math later, in step four, in all the work that you do to solve the problem, if every single constant and variable that appears in your computations, if it's first appears as a label in your diagram, then the diagram has served its purpose because what it's really trying to do is define the terms of your work. Right. Again, if you were to look, right, so the diagram has labels, the labels are letters. I could show this diagram to a random person who knows physics, and they would immediately know what's going, like they would understand the situation and then know, okay, when I use X naught from now on, I mean the place. Well, I could even be more specific. I could even say like, whoops, sorry. I could even say that X naught is the place where the initial velocity is zero. That's like really what I mean by that X naught. But anyway, the labels are letters. Then, if it happens to be the case, as it is with this first homework problem, if it happens to be the case that we're given numerical values, measurements for those constants and variables, then great. So I'm assigning those numerical values right underneath. That's what I mean by a fact pattern, diagram and fact pattern, right? So it's all there, but I don't, but the letters are the labels, and then I set them equal to numbers. And the reason to get into that habit is pretty quickly in this class, or pretty soon in this class, we sort of stop having numbers anyway. It all just looks like raw math after a while, physics. It's all just like situations in general. So you really want to distinguish between the letters and the numbers. All right, so that's my diagram. That is step one, diagram and fact pattern. Okay, then we're just looking in the chat. Hold on one second. Okay, everything's fine in the chat. Okay, we're good. All right. So then So now we go to step two. Step two, we're going to the particular question, the first question on the sheet. And the first question on the sheet, like in many English words, says like, what is the force exerted by the spring on the mass and on the instant that is released, right? But so I want to write that question. I need to know what the question is. But the point, or you need to show me that you know what the question is before you start answering it. The way to show that you know what the question is, again, is to not copy and paste my question. I already know what I think the question is. You want to put it in simple terms that are clear and probably simpler than what's phrased there. Certainly, you can use symbols and equations. In other words, this would be a perfectly sufficient way to write this. At okay, that's the question. Step two, what is the question? The question is, what is the value of f when x equals x naught? Or you could even say, what is the value of f when t equals 0? Like what? Same thing. That's the question. So I don't want all my original words. I want your version of it, and I want as simple a version as possible. So that's step two. What is the question? A couple quick things about that. It's much more. I really need that step for 1,000 reasons. Don't get for 1,000. It's a step that's so easy for people to skip, and it's so important. I need to know the question before I can move on. Again, this is part of this whole self-sufficient document thing. If you do these steps the way I'm asking, and again, I promise you, I'm very defensive about them because I know how stupid they seem at first to many people or how boring. I promise you, it's for life. Like I promise you, this is meant for the purpose of doing physics at a higher level and for doing original research and stuff like that. It's not meant to bring you back to kindergarten. It is meant to bring you forward, I promise. So saying what the question is like really important. But notice this, I'm now on question one. So I wrote what the question is for question one. Am I going to have to redraw this diagram for every single question? No, no, no. Just like on the original sheet, one diagram is applying to all these different questions. By the time I get to Q2, I'll write for step one, I'll write C above. Certainly you can do that. You should do that. You're not going to redraw the diagram, but you are going to acknowledge the need for a diagram and for definitions. So when you get to question two, for step one, you'll write step one or diagram C above or something like that. So you always acknowledge every step, even if you have something very quick to say about it. Okay, so that's step two. What is the question? Okay, so now I go to the next. So now, step three, general definitions and principles. Wait, I'm just switching the screen back. Is there anything in the chat? No. Okay. Also, for those of you, do you need to label your steps the way I am, like off in the mark? Yes, please. Like you don't have to write GDPWIQ. You don't have to, but do something like step three, step one, or like David put in the chat. I think this is what he's saying. He is saying, like make it clear what step you're on. Just like in a lab report or in a journal article, you would write you not only in a lab report or in a journal article, do you have a response? Let me back up for a second, because this is partly where I learned all this was like in graduate school. Like it seems like kindergarten, but really the second time I went to graduate school is where this got drummed into my skull that like, yes, every journal article or every lab report needs a section on methods and a section on results. Right? For example, you know this, or whatever you call it. People call it methods and results or data collection and results or whatever. Yes, every lab report needs those sections, but it's more than that. Because we need those sections so much, because every reader is expecting a method section in every report or in every journal article, they're expecting it so much that the writer actually has a responsibility not just to explain the methods, but before they explain the methods, to literally say at the top, methods. Like, no joke. Like, you have to label and say, here, I know what your expectations are, Mr. Reader, Mrs. Reader. Like, here it comes. You looking for methods? I got your methods right here. Like that you have to do that as a writer. And I found that out the hard way, believe me, in graduate school. Or even if you're doing an experiment where you don't think there are methods or something, where there aren't results or something like that, you still have to go, results? There aren't any. Like it's a communicate. Okay, you get the point. But you gotta not just do things for the reader, you gotta make it clear that you're doing the things that the reader is looking for and that you know what they are. Okay, anyway, so step three, you would label, that means general definitions and principles. Now, what is that? Well, in seventh grade terms, that means like, what do you know already, right? Except here's an interesting thing. Didn't we kind of already do that in step one? In step one, didn't we already write down what we know? So what the heck is this then? Well, in step one, we wrote down what we know about this particular situation. And then we presented the question that arises from this particular situation. Now, in step three, we're backing up and saying, what do we know about the universe even before we looked at this situation? What general truths, definitions, principles, laws, equations do we already know as physicists that we think once we stumbled into this situation, we think are going to be relevant or helpful to this situation? So this is the general knowledge thing. This generally means this is like definitions and equations. Okay, so for this question, you see where this is going, and generally those are the kind of things that right when you walk into class, like you'll notice examples of step three GDPs are right here on the board. Like when you walk in, like those are just examples of like GDPs that will come up today. Oop, and one of them has an arrow. I'm sorry, hold on. There should be an arrow there. Okay, so yeah, I think the general definition or principle that we're going to use right here in this situation is Hooke's law for a spring. And let me say, general step threes are generally equations, but they can be English as well. They just what they have to be is a complete thought. So that happened. Oh, it drives me crazy. Sorry.
Professor, we can't hear you.
Oh, sorry. That's you know the reason you can't. Thank you. By the way, was that Mohammed again, or because you
Yeah.
told me? Okay. The reason you couldn't hear me right then is because I wasn't saying anything. Sorry, I was just writing this down before but I will say something in a second. But thank you. That you really are paying attention. That's awesome. Um, okay. I'm just writing this and then okay. Okay. Now, I'm writing the step three GDP. Partly I'm dragging it out a little bit here. I'm like over saying it because partly I'm being a teacher right now and I want to teach it to people in the room that don't know it. You don't necessarily have to get this elaborate when you do the homework or an exam. When you do a GDP, step three, basically I'm looking for the equation. And yes, you do need to explain any equation that you write down. You at least need to explain it the first time you use the equation. Then throughout the rest of the homework or the rest of the whatever, you don't have to keep re-explaining the same thing. But so the principle or the law or the definition that I'm going to use here to solve this is Hooke's law for a spring. F equals negative kx. Um, um, Now some of you are more familiar with that than others, depending on like where you took physics last semester and who you had and stuff like that. Um, so let me, well, all right, let me pause for a second. Just raise your electronic hand if you've ever seen that law before in a prior physics class. I'm not, one, two, okay, okay. Caitlin, thank you. Lear, thank you. Anthony, thank you. Dave, keep them up for a second. Caitlin, Yediah, Roger. Oh, okay, great. Victoria, oh, a lot of you. Okay, okay. Good, good, good. All right. So I won't, okay. So I'm going to try to do like a compromise. I'm just going to try to like summarize it, but definitely tell, this is going to be one of those moments where you guys, I'm glad it looks like a lot of you. That's good. It's pretty important law, especially for this unit that we're doing. So I'm going to try to give like a quick summary of it now, but you could tell me in the private chat whether you need to hear more when I'm done or you need to hear less and you need me to move on more quickly. But the quick summary of this is this. And again, everything I'm writing right now is you could do it the first time you're explaining a law in homework, but then you don't have to like keep doing this every time. But you'll never be punished for too much explanation. I can assure you of that. Um, so okay. So I'm going to say, so first of all, I want you to know, if you've never had me before, we use something that's true in physics. I didn't make it up, but people often don't know it until they get to a certain level of physics, is there's two types of equal signs. There's two types of equals. A double equal sign, a regular equal sign that you use all the time, the two lines, that means equal by discovery or condition or circumstance. I'll say that again. The regular equal sign that everybody's used to with two lines means equal by discovery or circumstance or condition. If you make an equal sign with three bars, like I'm doing here with K, a triple equal sign, that means equal by definition. And I will use that from now. I mean, again, I've shown you to some of you that before, but I will use that for the rest of this class. So if I use triple equal sign, it means equal by definition. And if not, not. So anything that's true by definition, I mean, if it's true at all, then it's always true, right? If it's true by definition, but double equal signs are softer. They're not necessarily rigidly always true. They just like they could be approximate. Anyway, you get my so here's what I'm saying with this graph. I'm saying what it means to be elastic, what it means to be made of a springy material or to be an ideal spring is that the end of the spring wants to be somewhere, wants, and where there's an equilibrium position associated with the spring, and we call that position x equals 0. That equilibrium place is the place where if you put a mass at that location, if one end of the spring were fixed to a wall, and then you placed a mass on the other edge of the spring, if the edge of the spring were at the equilibrium position, then by placing the mass there, it would stay there. It wouldn't move left or right. But if you hold the mass anywhere other than the equilibrium position, if you stretch out the spring a little bit to the right, or you squeeze and compress the spring a little bit to the left, let's say, Then you let the mass go, it's going to start accelerating toward the equilibrium position. The equilibrium position is the one and only place where things will sit perpetually. We call that x equals 0. So it turns out that if the edge of the spring, if the mass on the edge of the spring is at any x position other than 0, the spring will exert a force onto the mass, trying to restore the mass toward the equilibrium position. Sorry. Like if the mass is on the positive side of 0, which in this case we're calling to the right, if the mass is on the positive side of 0, then the spring will exert a force pulling it to the left, hence that negative sign, towards 0. If the mass is on the left, is in the negative on the other side of 0, if you're compressing the spring, then the spring will exert a force trying to bring it back to 0. Negative times a negative equals a positive. So we'll try to pull it back toward the positives. That's all, I'm sure. I mean, you've had that experience with spring. I mean, I would imagine that that's like not a surprise to me. Oh, and I guess you looked at it in the, if you had lab last week. Did you have lab last week? Wait, sorry, very quickly. Did you have lab last week? You did. Thank you, Victoria. I totally saw that.
Yes.
Yes.
You did. Okay, great. So you saw this in the lab. Okay, great. And thank you for all of you who just participated. That's points for all the. Oh, just so you know, there's a portal for that. For anybody who just like nodded their head at all, or like certainly Victoria, for example, I happened to see, but she wasn't the only one. There's a portal that says for right or for wrong. That's like anytime you answer a question at all and you're taking the risk of being right or wrong. Like I'm serious. Like if you look at that portal, you, Victoria and others, you could just like say, I answered the question of whether we had lab this week. I said yes. And and submit to that. Like seriously. But anyway, so I think what I just said about springs you already kind of know or is comfortable, but here's the catch now. Here's the whole business with K that is important, whether it's obvious or not, is that everything I just said is also true of gravity, right? I mean, if you hold something above the ground, if you hold something above the ground, a mass, well, planet Earth will exert a force trying to bring that object back to the ground, a force of negative mg, right? I mean, if up is positive and if down is negative. So if I'm holding a mass over here at height 5 meters above the ground, center of the earth is going to pull down on that m with a force of negative mg and try to bring it to the ground. Just like a spring will try to pull a mass toward the equilibrium position. The difference is the big deal of a spring or of Hooke's law, just to remind all of you or to tell some of you for the first time, the big difference is that gravity is constant near the surface of the earth. Like if I hold something at a height of 5 meters, the force that gravity is exerting on it downward is negative mg. But if I hold the mass at 10 meters, the force is still mg. The force doesn't care how high the object is within reason, as long as I'm near the surface of the earth. It just cares that I'm not on the ground. But with a spring, what we're saying is what this graph is trying to say is two things. One, the farther out you hold the mass from the equilibrium position, the harder the spring will pull to get it back. It will exert a force that is directly proportional to the displacement from the equilibrium position. In other words, the force expression has an x in it, right? Unlike the gravity expression that does not have a y or x or r or whatever, right? So it has an x in it, but then it has a negative sign because it's going to pull back the other way from wherever x is. It's called a restoring force. But then also notice, just quick review, whatever, notice this graph, notice it's not f equals negative kx squared or negative kx cubed or anything like that. It's literally negative kx. So it is a linear function. The force is dependent on x. So that's sort of like the bad news. It's more complicated than gravity. But the good news is it's as simple as that kind of complexity could be. It is dependent on x, but in a linear fashion, in a directly proportional fashion. the graph is just like y equals mx plus b, only b equals 0. When x is 0, the force is 0. So you get this straight line relationship between how far you pull out the edge of a spring versus how hard the spring is pulling in order to get the thing back. So it's a straight line. What does straight line mean? It means constant slope. What is the slope of this line? The slope of this line we call K, where K, right, is the rise per run, the rise in force units per run in displacement units. So the units of K, right, whenever I use square brackets, it means I'm talking about units. So the units of K are always newtons per meter. K is a constant. I mean, you saw this in the lab. I'm probably dragging this out more than is necessary, but K is a constant for any one given spring, but it's not constant from spring to spring. K refers to how many newtons of force that spring will exert per each meter of displacement that we subject the end of the spring to, right? So K is measured in newtons per meter, and it's a number, and the bigger the numbers, the more newtons you're getting for every meter. So what does that really mean in English? It means it's the stiffness or the strength of the spring, as you saw in lab 1, right? So a 200 Newton per meter spring is a tighter, stiffer, stronger spring than a 55 Newton per meter spring. Okay, I probably shouldn't have. Now that you saw that, so that's clear, right? Oh yes, she said yes. Thank you. So now, okay, so I can go on, right? Like, just raise your hand if I can move on. Like, you're fine with that, yes? I think you could. Someone, thank you, Gabriel. All right, and thank you, Latchman. Thank you, Roger. Thank you. Okay, great. All right. And again, do you have to put all of that explanation in your homework? No. Well, let me be really honest and really clear. Do you have to put all that explanation for something like F equals negative KX or like F equals MA or so? No, you don't. But as things get harder, like, to be super honest, question 9, which of course we won't get to today, but by the time you get to question 9, especially if you found things on the internet about like differential equation or solution to differential equation or like cosine omega, then you really do have to explain that stuff. Like, especially anything that you're getting from the first time from the internet, like, that's not cheating. You can learn whatever. I mean, like Quark plus America, like, learn things however you want to learn things. But if you are learning them for the first time, you definitely need to explain them. If we've never said, okay, so like, anyways, this is a model. So you don't have to do this much, but this is a model of what it means to explain. So that's step 3. Step 3 is F equals negative KX. Okay, now I move on to step 4. And step 4 is particular application and work. Oh, this ends in 17 minutes. Okay. So how do I usually know that how do I know that I'm like transitioning to step 4? Or what does it mean? Like, step 3 was the general definition, or the general definition, or the principle, or the law, the equation, the general truth. Now I'm I'm zooming in to step 4, where I'm going to apply that to the particular problem. So the way I usually know that I'm like moving into step 4 now is I usually signal myself with a word like here, like as in here in this situation. So now I'm going to like plug in values and deal with units of measurement and scientific notation and all of that. In other words, here, like, okay, we said K equals 200 newtons per meter. We said X equals the initial value of X, which was 0.15 meters. And M equals 0.3 kilo. Oh, we don't need the, I'm sorry, we don't need the M. Right, so like I'm including units, do all that like science stuff that we ever did in chemistry or physics 203 or whatever. Right. So that's my step 4. Now, of course, you can imagine once problems start getting more elaborate or harder, this will involve like trigonometry, calculus. Like, there may be a lot of things to do here in step 4. Here it's kind of straightforward. So then I work through all that stuff and I do all the scientific notation, all the units and everything. And I finally get to step 5, which is final answer.
Professor, I'm sorry. I don't understand what's the difference between step 4 and step 1 because I wrote already what's K and what's X and I
That's
didn't
a
write what's F.
That's a really good question. And okay, so two things. And it'll start being so really what I'm saying is step 1 is the facts and step 2 is the computation. Now there will be a little bit of a repeat, a little bit of an overlap, but like, so in step 1, I wrote all the facts, the K and the F and I'm sorry, I mean the K, the X naught, and the M. Now in step
Yes.
4, right, okay, and that's good, yeah, and it's a good question. But now in step 4, I'm actually now going to plug in the correct in the relevant values into whatever equation or law that I'm using here.
So I
So
just want to know if I should write again what's K and what's X. It's not enough if I just write F equals blah, blah, blah.
yeah, I mean, I guess if you just write F equals blah blah blah, it's probably fine. It's probably fine. But I would just maybe be a little bit careful, or just when in doubt, give me more
Okay.
rather than less. Yeah, because partly you're right. I mean, we don't necessarily have to say it again, but partly, just notice this. Partly, when I did in step 1, I included everything, the K, the X, and the M. Now, partly what I'm trying to do for the reader is focus the attention on just the things that we actually need right now. So you could also just say for K and X, see above step 1. I mean, you could do that too. But I just want to make sure that now yeah, but yeah, you could use your judgment. But here I'm plugging in, I'm doing the equation out, and then step 5, I'm saying the final answer. And the final answer is this. Okay. And with all this, I mean, with Lear's question, I mean, all of this, you use judgment. I mean, there's all of your homework, eventually, they're all going to look slightly different. They'll be your personality. And believe me, I will also use judgment. I mean, I'll be generous. I'm not looking to take off points. I can tell you all that. Um, and the more elaborate these problems get, the more you'll find your way to do it. Um, But notice this now in step 5, I'm putting a final answer and I'm circling it. Notice a couple of quick things. I know we have 12 minutes left of the class. First of all, my final answer is a complete thought. It's a complete sentence, i.e., it's an equation. It's not an equation with triple equal sign. It's an equation with double equal sign, but it's an equation, meaning my final answer is it's not just like 30 or something. It is when X is 15 centimeters from equilibrium, then the force being exerted onto the mass is negative 30 newtons. Like, it is a complete thought. If it's English, it has a verb and a noun. If it's math, it has an equal sign. Furthermore, notice that my final answer literally refers back to my original question of step 2. That I should see the match. Like, step 2 is when X equals X naught, what is F? Step 5 is, oh, when X is X naught, then F is negative 30. I have closed the book on the problem. Let me emphasize again. Now, of course, again, to everybody, hopefully I'm dragging this out in a situation where you pretty much all of you already know the answer. So it's like hopefully the physics is not the hard part right now. But notice if you literally do all these steps and you label them the way I'm doing, and you go and I see here's a situation, or I give this to Professor Walters or Professor Talley or Professor Boyer at City College or whatever, like somewhere else, and I hand it to them, like they could follow. They don't need any other sheet. They don't need any copying and pasting. They don't need to know what class this is. They would just look at it and go, oh, that's a situation. Oh, that's the thing you're trying to figure out. oh, that's what you did? Oh, you followed that law? Oh, and that's what you got? And they'd be like, oh, that's amazing. That's awesome. That's perfect. Or this is not right over here. And yes, this is like an old problem. It's not like a big, like discover, like no one's going to give you $100,000 for this discovery because we've done it a million times. But you can imagine if it's a slightly trickier, more original problem or something you did in the lab, then you've just proven something. Like you have, if you do this correct, we just proved this is how you get the force exerted on a spring. It's just this isn't so interesting because many people have proven it before. But you want to imagine this as like a journal article that you could give to someone. That's the point. And they'll know if step 5 links back to step 2, then it is coherent and clear and organized. All so much so, I'm saying to everybody, so much so that by the time the physics starts getting a little bit harder in this class, if you do all of these steps, you're getting credit, you're getting points for all of these steps, whether it's homework or exams, so that even if your final step 5 is actually wrong, fork forbid, say your step 5 is actually wrong, if you did all these steps and you did them like this, well, first of all, there's a great chance that your step 5 is not wrong. But if it is, it's still very possible to get the overwhelming amount of credit for all of this. It's very possible to have a lot of wrong answers on homework and on exams and still get an A in the class. It is. And if you're doing all that, so the reward, I mean, even if you think this is all boring and annoying waste of time right now, if you do the steps is the way I grade. If you have the steps, you get the credit. If you don't have the steps, you don't get the credit, even if the answer is right. So you want to do the steps as like, this is how you're getting the points in the class. And the truth is that if you do the steps, you probably will get the right answer. Last thing I'm going to say again, the steps, see if right now, any of you, and I believe, may I already mention this, maybe, believe me, I'm the guy. I am the guy who, if I was in this class 30 years ago, if I'm in a college physics class and the professor is sitting here walking me through step 1, step 2, step 3, and I'm seeing in my mind, oh my God, I mean, it's negative 30 newtons, for heaven's sake. Like, when can I eat lunch? Like, believe me, I would be the person 30 years ago who'd be like, you're kidding me. I have to do all of this to get negative 30 newtons? Are you kidding me? I, I sympathize if you find it very frustrating to have to do this, but let's be clear. It's frustrating if it is frustrating because it's boring, because it's extra work that you don't feel like doing, but not because it's hard, right? There's nothing hard about this. It's just annoying. So I think that's a reasonable price to pay for the idea that when you get to problems that are harder, and we will, and believe me, I did, as if I was also the guy that even though he signed up for physics major, I wanted to do physics with my life. I did it in college. I went to graduate school twice. But I got to the point very quickly where I would get assignments and exams where I would look at the question and go, what? WT, well, they didn't have WTF then, but I would say, WTF, are you kidding me? I don't even understand what this question is asking. I have no idea what you want me to do with this question. I was that guy too. By the time I would get to exams, like, what are you freaking asking me to do? I don't even have any idea how to start this. If you've ever been that person, or you've ever been the person who says, I can sort of follow physics, like when the person does it in the class on the board, I get what's going on, and I can even sort of do it at home, but I often get stuck on how to start. If you've ever been that person, and I think many of us have or will be that person in this class, if you're ever thinking, I get it when he's talking about it in class, but then I go home, I can sort of do it, but I don't really know how to start. I'm here to tell you the reason that people often think they can get it and think they understand it, but can't start a physics problem on their own is because we're all trained without realizing it to start at step 4. I'm here to tell you step 4 is the thing that looks like showing all your work. And when people tell you to show all your work, what people tend to do is jump right into showing the computation. And the computation is the math. It, if you can do that, that's good, that's great. That means the math is not your problem. But if often you're thinking, I can do it once I get rolling, but I can't start on my own, what you're really saying is, I can do the math, but I don't really understand what the physics means. And the way to know how to start, the real secret that took me years to realize is don't start with step 4. Start with step 1 and 2 and 3. And if you look at steps 1, 2, and 3, the reason they are boring, the reason steps 1 and 2 and 3 seem stupid to many of you, I'm not making fun. I mean, I'm serious. The reason they seemed stupid to me when I first looked at them, they seem stupid and boring and a waste of time, because if you really look at steps 1, 2, and 3, they are steps that you can almost always do without even understanding what the question's asking. You can do steps 1, 2, and 3 without even understanding what the question's asking, let alone know what the answer is. That's why they're boring, but that's why they're crucial. Because steps 1, 2, and 3 is what you do when you don't know what to do. When the questions get hard enough that you can't see the answer right away, or you're not even sure what they're asking, if you first make a whole diagram, then literally try to write down what the question's actually asking, and then literally write down the equations that apply to it, then those will launch you into step 4. They will set the table for you so you can naturally do step 4, and it brings you to step 5 and you get an answer. That's what I'm saying. When things get hard, being used to doing step 1, 2, and 3 first is the habit that will save you and will get you the right answers. But even if it doesn't get you the right answer, you just got points for doing step 1, 2, and 3 in this class. So it's worth to. So it's all about do step 1, step 2, step 3, step 4, step 5. You get all those points, even when you're not totally sure you know what you're doing. It will do the work for you. Okay, I know I'm going. But that's what I just did. I'm looking at the time. We have 4 minutes. What I just walked you through is what I'm looking for every time. I am. But of course, you don't have to be repeating. You could put in step 1 for diagram, see above. Or like step 3, if you're going to use f equals negative kx again, you could say for Hooke's law, see above. Like you don't have to keep repeating, but you have to acknowledge each step. The feeling that, that's hilarious. Oh, wait, I'm looking in the chat. Funny things are happening in the chat. Are you kidding? Wait, what? Yeah, okay, that's funny, Mohammed, I think. And for me, and I'm gonna need to, I have to open up a portal for like fun times too. You all get, but yeah, seriously, that feeling never go. It does. You're talking about what I think you're talking about. No, like for all of you, I'll stop yammering about this. We'll go on, but like if you're doing what you love, which might not be physics, but if you're pursuing what you love, if you have found what you love, your career, your science branch, whatever, even if it's molecular biology, I mean, Cork bless America. No, but whatever it is that you love, if you're doing what you love, you're going to get to a point in doing it where you get challenged to your level. Otherwise, you're not doing the right thing and you're not doing it hard enough. You will, and yeah, then that feeling never goes away. That feeling of what the but what I'm here to really teach you, I will shut up, I promise. But I want you to know, yes, I'm here to teach you physics, of course. But who are we kidding? You have Google and Wikipedia and like Khan Academy. Like, there's so many ways to learn information now. Why do you need a professor? Why do you need to pay college tuition? What you really can get out of me is the experience of what it's like to learn something hard and how to get better at it. That's what Google cannot give you yet, or ChatGPT yet. What I can tell you is I chose to do physics for my life, and it was hard. It was. What I have learned is what to do when I don't know what to do. That's what I'm here to show you. What to do when you don't know what to do. That's what it means to get smarter, not to just get more information and fit into the smartness you already have. Okay, so that's what this is all about, I promise. And the trick to getting smarter and doing harder things is to make them easier, to make it look like kindergarten or seventh grade or whatever. Okay, it's not meant as an insult. It's not to say that many of you are way smarter than I am, but I'm telling you the one smart thing that I have figured out of how to be smarter is to make things dumber for me to deal with, like for real. Okay, so that's so real. Okay, cool. So we only have 1 minute. So what I'm just going to do, we have like literally 1 minute. Of course, we'll continue this Wednesday. You get, again, if you didn't get all the points on your homework, but you got any points, you can resubmit and eventually get all the points. And you don't have to do it tonight. You can wait till I go over more on Wednesday and you can resubmit based on what I do on Wednesday. Totally fine. More than fine. I'll just quickly say, to have 1 minute, I'll say the answer to the next question. I'm just going to say these just so you know if you have perspective. I think the answer to the next question is negative 100 meters per second squared, negative 100 meters per second squared. The answer to the question after that is 0 meters per second squared. I'm saying this fast because I will go over this Wednesday, but just so you know, the answer after that, and now it gets a little harder. question 4 starts getting harder, well, of course we're going to talk about it. But I believe the answer is 3.87 meters per second, or V equals 3.87 meters per second. And the answer to number 5 is X equals 0.095 meters. So if you got those answers, you're good. That just means they're good. Then and if not, we're going to talk about it Wednesday. It's all good. Thank you for being so patient. Yeah, so if you have any questions, you can stay for a minute or two. But then I have another thing. So yeah, stay for. I will turn off the recording. I'm still here until everybody goes. I'll be the last one to go, but you can go. Have a nice community hour, whatever.
See you, Professor.
Thank
Thank
you,
you.
Professor.
Thank you.
Goodbye.